Okay, so I'm just going to walk through this lab for you really quick, and you can kind of fill in as I go, or if you just want to watch this first and then try to do it by yourself, that's fine. But I just thought this would be a little bit helpful to kind of see what you're actually doing. So this is a lab that we actually would normally do in class. So what we've done is you kind of have a little design section where you would normally work with your group for this. So since you don't really have a group, I don't want you to have to struggle through by yourself, so I'm going to be your group. So I'll kind of walk us through what we're going to do for the first couple parts. And then at the end, towards the end, there's a little video link. It's like a 6-minute video, and it kind of just walks you through what you would actually do in the lab. And then you have some observations to fill out at the end. So the first part, basically what you're doing is you work for an industrial chemical company, and you've been given the task of reclaiming some copper metal that's actually in a solution of copper chloride. So in our beaker here, we have a little copper, is it my pen? Sorry, my pen wasn't working. A solution of copper chloride. So what we're trying to do is we're actually trying to get this copper out of solution so we can actually use it for other things in our company. Okay, so what we've figured out will work is that we want to perform a single replacement reaction. Okay, so remember that's when we have some other type of element, right? We'll call it X, that we can add into this solution, and we want it to kind of kick out copper. We want to take copper's place in this solution, so then we end up with copper by itself. So what we're going to do is we have a little chart here. These are our options. So we have aluminum, magnesium, mercury, and silver. We have their prices. And then we want to know, well, first, is it even going to react in this reaction? So in order to do that, what we can look at is what we call an activity series. And basically, it's just kind of showing which elements are going to react better than others. As long as an element is higher up here on our scale, then it will replace copper. So here's copper. Okay, so as long as our element is higher up than copper, then it's going to replace it. If it was lower down here, that means it's less reactive. So it's not going to actually replace copper. It's not going to be able to have the strength to kick copper out. So we want to be looking in between the top and this copper here. So the first one we have is aluminum. Okay, so here's aluminum. So aluminum, will it react? Yes, it will. Magnesium? Yes, it will. Mercury is Hg. That's down here. That's below copper. So that's a no. And then silver is also down here below copper. So that's a no. So again, they're just not strong enough reactivity wise to replace copper in this reaction. Okay, so we want to kind of look at aluminum and magnesium. So the next question, it says, out of those metals, we want the one that's least expensive, right? Because we're working for a company, we want to save some money. So which one do we think we want to use? Well, aluminum's only $3.54. So my best metal is going to be aluminum. Okay, so that's kind of the process that we would go through to look for this replacement. So here's our equation. Okay, we have our single replacement reaction. So now we need to balance our coefficient. So if you want to pause it, try to balance it real quick. That's fine. This should be a little arrow. It just didn't translate in my PDF very well. So I'll kind of balance this out quickly. Let me do my chlorines first. I need a 2 there and a 3 here and a 3 here and a 2 here. So I've balanced my equation. Now what I need to figure out is how much copper am I trying to get? So how much do I need to start with? So our goal here, what we're trying to find, our company, we need 0.2 grams of copper, okay? So in this experiment, we need to get 0.2 grams of copper. So what we're going to kind of do is work backwards. We're going to figure out how much actual copper solution we need to start with in order to get that 2.2 grams of copper. Okay, so what we can do is we can actually use stoichiometry to find that. So I'm starting right here with what I'm given, the 0.2 grams of copper. Okay, so next I would have to go to my grams to mole. How can I get from grams to mole? I would use my molar mass, and I've actually given that to you right here. So that would go down here on the bottom. So I've got 170.49 grams for every 1 mole of copper. Okay, when I get here, this is where I'm going to be using my mole ratio. So I'm actually going to look at my, and I jumped the gun here. I'm sorry, I was jumping to copper chloride. This is just copper. So where am I going to find my grams per mole of copper? I'm going to look at my periodic table. And copper is 63.55. Sorry about that. All right, so my grams per mole, there's 63.55 grams of copper and 1 mole of copper. Now I'm going to use my mole ratio to get from my number of moles of copper to copper chloride. So I'm going to look up here in my formula. So up here I have 3 copper, so now that's going to be a 3. And then copper chloride, I also have 3, so that's going to be a 3 as well. Okay, and then in order to get to grams of copper chloride, right, so my grams of copper have canceled, my moles of copper have canceled, my moles of copper chloride cancel here, and I can go from moles to grams, okay, using my molar mass. This is where we're going to use this molar mass that I've given you here, 170. Okay, so all I'm going to do now, I'm just going to plug it in my calculator, multiply across, divide by the bottom, and I should end up with how much of this I need to start with. Okay, and this is actually like a little powder, and you'll kind of watch this in the next video, but it's like a little powder, and we're actually just going to add it to some water. Okay, that's basically how we make our solution. Okay, so here on your document, you'll click this hyperlink right here. It's going to show you a quick little 6-minute video. Like I said, in that video, that's where you'll get all your data for your table. It's going to have a little digital scale in the video, and it'll show you your different masses. And there's also some observations you could make, like color changes, if there's some kind of other solid or precipitate. That's what precipitate means. It's like a solid that's produced. Okay, so you can use that. Once you've watched the video, then you can move on to part 4. Again, this is just showing some observations. So you can kind of see what we're starting with. We've got our copper chloride solution over here, and then we've got our piece of aluminum right here, okay? And then what happens in our reaction, some of our aluminum solid actually gets put into solution, and we're gonna pull out some of our copper. So you're just making some observations right here in these spots. And that's just kind of like, from the picture here, what are some observations that you could make, okay? Number 2, you're just kind of looking back at your data table. So it's your initial mass of aluminum and your final mass of aluminum. That's up here, these two right here. You're just subtracting those two. You want to know basically how much aluminum was actually reacted. Okay, how much was actually used in the reaction. So you're just going to subtract those 2 boxes, okay, and you'll get an answer. Okay. So here, what we're going to do is we've figured out, right? This was our 0.54 grams of copper chloride. That's how many grams we had to start with. That was your answer back up in part 1. So what we want to do now is we want to say, well, if we started with this much, how much aluminum was actually going to react? Okay, so this is kind of where we're double checking how much actually reacted versus our theoretical, what we thought was going to react. Okay, so we're going to plug all of our answers in just like we did before. Okay, so I'm starting with grams, copper chloride. I know I have to get from grams to moles. So this is my molar mass that I was given earlier, right here, right? It's how many grams are in 1 mole. That's my molar mass. Then here, this is where I'm using my mole ratio. Okay, so I'm going to go back to my original equation, which is up here. And I have 2 moles of aluminum for every 3 moles of copper chloride. So I'll scroll back down, 2 moles of aluminum for every 3 moles of copper chloride. Okay, and then here, now I can go from moles to grams. And then we get our grams here. This is our molar mass. So on our periodic table, what is our mass of aluminum? Okay, what is that number that's going to go right there from the periodic table? Same thing, we're going to multiply across, divide by the bottom to get our number of grams of aluminum. Okay. And then our number 4, the last question, we're going to do our percent yield for copper. Okay, so how much copper did we actually get in our equation? So, or in our experiment. So our theoretical yield is the 0.2, right? That's how much we wanted to make. That's kind of what we based all of our data on. All of our calculations was on this original value, 0.2. I'm going to get the actual number that I produced right here. So this is my actual copper. Okay, my mass of my copper product. So whatever number you have in this box here, that is what you will put right here. Okay, our number of grams. So once we divide that, multiply by 100, okay, that's going to give you your percent yield. So it's kind of a multi-step process. Hopefully just me walking you through it made it make a little bit more sense. Once you see the video, if you want to even watch the video first, you could always do that, just to kind of make it a little bit more clear. But make sure you do watch the video so you can kind of see what you actually would be doing in the lab, and then make sure that's how you get your data. If you have any questions about any of it, or want me to walk you through like in a virtual conference, I don't mind doing that. Just send me an email